Namaskar, welcome to Exercise Explained. In this video, I would be doing question number 5 and question number 6, exercise 3B, machines, ICSE 10th physics. The previous questions have been done in the previous videos, the link for which will be provided in the description. If you like the video, do share it with your friends and consider subscribing to the channel. Starting with the 5th question. So a block and tackle system has 5 pulleys. So there are 5 pulleys in the system. So as soon as I see 5 pulleys, I will write the velocity ratio. Velocity ratio is going to be equal to 5. If an effort of 1000 Newton, so the effort that is given here is 1000 Newtons. I would write the effort here as 1000 Newtons. So E will be equal to 1000 Newtons is needed in the downward direction to raise a load of 4500 Newtons. So the load is given as 4500 Newtons. So the first thing we need to find is the mechanical advantage. So I would write load is equal to 4500 Newtons. So the mechanical advantage formula MA will be equal to load divided by effort. So MA will happen to be, the load is 4500 divided by effort is 1000. So we get mechanical advantage as 4.5. So I've got the value of mechanical advantage as 4.5. The velocity ratio, I've already told about velocity ratio. The velocity ratio is straight away going to be 5 here. Coming to the efficiency of the system. So for finding the efficiency of the system, we write it by the symbol eta. Efficiency is equal to mechanical advantage divided by velocity ratio. So for us, efficiency will be equal to mechanical advantage is 4.5 divided by velocity ratio, that is going to be equal to 5. So 4.5 by 5, I multiply numerator and denominator by 10. So I get the value of efficiency to be 45 divided by 50. So the efficiency happens to be 9 by 10, or we can write it as 0.9 or 90%. So 90% is the efficiency of the system. So hope this question is clear. We have got all the 3 parts of it. Now getting into the 6th question. In figure, draw a tackle to lift the load by applying the force in the downward direction. So I have already got the figure on the right side. Mark the diagram in the direction of load and effort. So we can see that the load is being marked here. The load is marked here, right here. So that would be our load. So I can write it as load. And the effort is over here. This is the effort. So now we need to write all the directions for it. So the system actually starts from here, the point right here. So this is where the system starts from. So from here it goes round. Let us write few numbers for the pulleys. So let's say this is pulley number 1, this is pulley number 2, this is pulley number 3 here, 4 and 5. So it would be easy for me to explain. So this is where the arrow mark is where it starts from, goes around the pulley 3 and the tension down to pulley 4 and then to pulley 2 and then back to pulley 5 and then finally to pulley 1 and then to the effort. So this is how it's going to be. So this happens to be the first part of it. After this, if the load is raised by 1 meter, through what distance will the effort move? So for finding this, we would be needing the velocity ratio, and as there are 5 pulleys, I would straight away write the velocity ratio as equal to 5. So now for velocity ratio, we have a formula, that is velocity ratio is equal to distance moved by the effort, that is dE, divided by distance moved by the load. Now as we can see in the question, load is raised by 1 meter, so that is dl, distance moved by the load, is given as 1 meter. So we just substitute the values in this equation. So VR happens to be 5 is equal to dE, that we are supposed to find out, divided by dl is 1. So we get the value of distance moved by the effort as 5 meters. So we have got distance, what distance will the effort move as 5 meters. So we are done with the B part of it. Now coming to the C part, state how many strands of tackle are supporting the load. So we will have to count the number of tensions that are working here. So let's count one by one. So yeah, so the first tension is going to be this one, this T over here. So that's going to be equal to the first tension. So I would write 1 here, and then the second tension would be this one. Sorry. Yeah, the second tension is going to be this one. So I would mark that as 2. So this would be our second tension. Then going around the fourth pulley and coming up. So this will be our third tension here. This T is going to be our third tension. So here I would write it as 3. Sorry. That would be 3. And then the fourth one here is going to be this one right here. So that would be the fourth one. So I would write 4 here. And after the fourth one, the last one is going to be this one, that is going from pulley 5 to pulley 1. So this is going to be our fifth tension. So this will be the fifth one. We will not be counting this tension because this is due to the effort and this will be equal to the effort. Please remember, this tension will not be counted. So how many strands of tackle are supporting the load? So there are 5 strands. So 5 would be the answer for this. That is for the C part. Now coming to the D part, we need to find the mechanical advantage. So for finding the mechanical advantage, I would be using the formula mechanical advantage is equal to load divided by effort. So I would write mechanical advantage is equal to load will be the number of tensions acting because of the load. That is our all the 5 tensions that we counted a few minutes back. So that's going to be 5 into T, because there are 5 tensions which are acting because of the load, and there is one single tension which is acting because of the effort, so that would be T. So now I can cancel this T and T and we get the mechanical advantage is equal to 5. So we have got the mechanical advantage of the system to be 5 here. I hope this clears this particular question. The next question onwards will be there in the next video, the link for which will be provided in the description. If you like the video, do share it with your friends and consider subscribing to the channel. So see you guys in the next video. Till then, Dhanyavad.